Good day, everyone. So my story today is about experience with this new standard in terms of testing glued-in rods. So before I start, there's a quote I want to share with you all, which sums up most of my presentation actually quite well. The quote is from the great Formula One driver Niki Lauda, who once said that winning is one thing, but out of losing, you always learn more. And this is a story of, I don't want to say losing, but this is a story of when testing does not go according to the plan, you are not successful in it in the way you thought you would be. So a little bit of context. So glued-in rods, it's a quite hot topic in research community for some years now, since this is a timber structure connection method that has a lot of potential in terms of its strength, its applicability, and its costs. However, there are, or at least were, a lot of drawbacks, chief among which was this lack of testing standards international, which sometimes led to results that are not comparable because everybody chose a little bit different method. So the story is, this new standard, basically what it does, it defines performance requirements and methods for determining whether or not we can use the adhesive and what are the strength characteristics. The basic scheme, as we try to do it, is the following. So you have an adhesive that you choose, you verify it according to testing methods, and then you do the testing of actual samples that are the ones that will be quite similar to those that would be in an actual building. The test methods are quite defined, and after you do this, you have all the data and you can feel confident that you are able to use this adhesive as adhesive for glued-in rods. So the problem is, what happens if you cannot verify the adhesive you chose? So how this happened for us? So there are four main test methods for epoxy and polyurethane adhesives discussed in this standard. So tensile shear test, delamination test, shrinkage stress test, and multiple compression shear test. These are all slightly modified methods from different parts of EN 302 standard, with a little bit of modifications in terms of glue line thicknesses and other small details, but the basic test method is the same. So we started with this, which is a test that a lot of us have probably seen. So you have these small samples that are 20 times 150 millimeters in dimensions, and their thickness is dependent on the glue line. So if you have what's called a close contact glue line, which is less than 1.0 millimeters, then you make this test sample out of two pieces of beech that are 5 millimeters thick each. When you do something for thicker glue lines, then the test sample looks something like this. And you have to do these tests before you try and do the actual testing of the real samples per se. So the samples are, of course, made of European beech. For us, the measured average density was 713 kilograms per square meter. Average moisture content was 12%. So a slight comment here that according to this standard, so you have to take into account the angle of annual rings for these samples. So when you make these samples, as you can see in this picture, you have to obtain what is called the herringbone pattern for the annual ring. So first problem, a small problem, is finding raw material good enough for these tests, but that's not an issue actually. It's just a small thing that you have to take into account. The adhesive we used was highly dense, two-component epoxy adhesive. So we used the densest adhesive we could find, because the very simple reason, this adhesive will have to be used at some point in a factory setting, and you will not be able to pour it in per se when it stands like perfectly vertically on your table in lab. This will be done for large beams that are lying flat on the floor or on a table or anything. So for the sake of doing these joints correctly, you have to take an adhesive that is quite dense, so it doesn't pour out that much. It cannot pour that much out from the joints when you do the manufacturing process of these joints in a factory setting. So the testing for the, we all know the glue tests. So the manufacture of them, as you can see here, this is the epoxy that we used. It's quite dense. So, and you make the thick glue lines with grooves that you fill in with the adhesive as you go. And the thing is that these samples, according to the testing method, have to be made with a pressureless gluing. So you cannot apply pressure as you would normally do when you are gluing something. So this is the deviation. So after you glue them together, you let them rest for a while, then you cut them into test pieces, and then you do the actual testing. So small samples, relatively fast testing, not a big problem. This is quite straightforward in terms of testing. You split the samples into at least 5 for us series. There are more, but these ones we didn't do in this testing. So the first series, there's no treatment at all, just conditioning in climate chamber, so 20/65 climate. So the next second series, it rests 4 days in water that's 20 degrees Celsius, and you test them in wet state. A3, you also soak it in the water for 4 days, and then you recondition it to original mass. Fourth and fifth, again, you boil it, then you put it in cold water. Either you test it in a wet state, either you recondition it to the original mass in 20/65 climate. This is quite straightforward, though it does produce quite a lot of samples. So you have 5 samples, 5 groups of samples. Each of these samples, you have to provide at least 10 valid results when you test. And also you're testing multiple thicknesses of adhesive lines. So you have close contact adhesive line, which, as I said before, is less than 0.1 millimeters. You have a glue line thickness of 1 millimeter. You have glue line thickness of 3 millimeters. So for each series, you're preparing at least 30 samples, which sums up to quite a large amount of samples that have to be tested. So testing was done on a universal testing machine. The loading rate that we chose, according to the standard, it can be up to 5 millimeters per minute. You have a time limit for this, during which you have to achieve failure. We achieved failure for most of our samples in around 80 seconds, and we loaded it with 2 millimeters per minute loading rate. So that provided us with the best results. And speaking of results, so this is the part when we start seeing that something wasn't right. So in bold, you'll see the average values of the samples we tested. In the brackets, you see the force that they had to withstand. So it's in newtons per square millimeter. So the point of this test is that you have these series, you have these sample populations, you have to break them, and it's a pass-fail principle. So you have to pass a certain strength parameter in order to be sure that this adhesive is adequate for our application. So for the non-treated series for close contact glue line, we had to achieve 10 newtons per square millimeter. We achieved 8.7. For 1 millimeter, we had to achieve 8.0. We achieved 7.2, and the list goes on and on. So basic thought is we weren't able to get the results we needed. Also, you have to check the amount of failure on the wood that you have. So in terms of how the percentage of how much wood is left at the failure zone. So for the first sample group that didn't have any treatment other than conditioning, so this was 90 to 100%. But for all the groups that had some sort of water treatment for them, so this was basically 0. For some, it was a small amount of wood left on, but basically they all failed on the adhesive line. So this started to give us some sort of clue of what might be happening. So what did happen? This is a picture of a sample that we didn't break because it had some flaws in it, so we left it as a residue. So if you can see the A and B ticks here, so the B is the glue line that you test, so that's the thickness of the glue line you test, and the A is just what holds basically the two pieces of beech together. According to the testing methods, so these values should be, so this was a sample for 2 millimeters glue line, so this bit here should have been 2 millimeters thick. In reality, so we measured it afterwards, and the average thicknesses range between 2.5 and 3.0 millimeters. And in here, where there shouldn't be any visible glue line at all, we still had 0.5, 0.8 millimeters of adhesive. So this was due to the fact that we are doing pressureless gluing, and we had a very, very dense adhesive. So we weren't able to obtain the samples that we needed to. And this is where the paper you'll see in the conference materials, this is where the paper ends. Unfortunately, we weren't able to put all the results in. To that, I'm sorry, but with you today, I'll tell you what happened afterwards for those of us who are here. So what we did, we repeated the tests with one slight change in the production process. So during the production of samples, we did press them. So we constructed the frame and we defined the thickness at which the pressure plates rest when they are pressing. So this was basically just to squeeze out the excess glue out of the samples, so we would get a sample that we needed to in order to do the tests. So this wasn't, they weren't pressed too hard, just enough so the excess glue pours out. And so the results were slightly better. However, still, although this adhesive, it was certified, all the papers were there, everything should have been great, we still did not achieve the results. And that gives us the question of why, in terms of conclusions. So in literature and from logical point of view, in manufacturing environment, you would want to use an adhesive that is dense because it's easier, and for factory workers that will actually be doing these joints, it is much easier to work with. So we're not thinking about lab technicians here, we're thinking about workers here. but we see that we have a problem with these dense adhesives. They do not perform in a way they should. So even with pressing, even with obtaining the perfect samples, we didn't achieve the results we needed to. And that is due to the fact that a dense adhesive cannot provide the sufficient adhesion to the wood to withstand the pressure. So a very dense, very hard adhesive, some of the samples actually did break when they were just put in the machine without any load at all. So further testing is currently being done. We're looking into this, of course, but the first conclusion from our side of view is that, of course, we should look into on how we can maybe adjust these testing methods a little more so they are for more appropriate for denser adhesives, and then we can see what happens. So this is currently being done. The results should be in a couple of weeks' time, but of course the conference is today, so this is our story of how something that should have been very easy did not work out quite well. I hope some of you took something from this, so you wouldn't step on the same things that we stepped on in here. I hope that our, I don't want to say mistakes, but our learning opportunities will also be your learning opportunities. So thank you very much for having me.